Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the fifth question from the mid-year examination which was written in the province of Eastern Cape in the year of 2024. Please do expect a total number of 7 videos since the question paper had 7 questions in total. That simply means each and every question will have its own video. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your preliminary exam, your mid-year exam, and most importantly, your final examination. So please guys, do share the video to your peers so that they may have the same edge as you. And please do help us grow the channel by just subscribing. Okay. We are told that a group of learners used the reaction between magnesium carbonate and excess hydrochloric acid to investigate some of the factors that affect the reaction rate. The balance equation for the reaction is given below. Okay, we do have our magnesium carbonate and hydrochloric acid. And then for our products, we'll simply have magnesium chloride, water, and carbon dioxide. Okay, the learners used the apparatus illustrated below. Okay, we have our conical flask. We also have our gas syringe to collect the carbon dioxide gas. And then inside the conical flask, we do have our reactants, which is magnesium carbonate as well as hydrochloric acid, which is in excess, by the way. Né? So since the hydrochloric acid is in excess, it simply means that our magnesium carbonate is our limiting reagent. Okay, let's check guys. Okay, the table below summarizes the reaction conditions. Okay, so the learners guys conducted 3 experiments. In experiment 1, they used a concentration of 0.9 moles per cubic decimeters of hydrochloric acid, and the state of division of our magnesium carbonate is in powder form, and then they used room temperature, or rather they used 25 degrees Celsius. Né? And then for experiment 2 and 3, the concentration of our acid is the same as well. However, the temperature is 30 and 30. That's different from experiment 1. And then the state of division in experiment 2 is in powder form, but in experiment 3 is in a solid form or in a form of a lump. Okay. Firstly, they want us to define the rate of reaction. Né? Rate of reaction, guys, is just the change in the concentration of reactants per unit time, or you can say it's the change of the concentration of products per unit time. Okay. Now they're saying write down the independent variable for the comparison between experiment 1 and 2. The independent variable, guys, it must always be the factors that affects the rate of reaction. Are you together? And then our dependent variable is always the rate of reaction. So in this case, guys, whenever we check experiment 1 and 2, the only difference is temperature. Are you together? In experiment 1, we used 25 degrees Celsius, and in experiment 2, we used 30 degrees Celsius. So the independent variable over here is just temperature. Okay, and then now we are told that experiment 2 and 3 are now compared. Which experiment 2 or 3 will have a higher reaction rate? Both experiments, guys, have the same concentration of the acid. Both experiments are held at the same temperature. The only difference is the state of division. Are you together? Experiment 2, the magnesium carbonate is in powder form, but in experiment 1, the magnesium carbonate is in a solid form. Are you together? So the one that, guys, takes place whenever the magnesium carbonate is in powder form will have a higher rate of reaction, because whenever we are making our solid, whenever we are changing our solid into powder, we are actually exposing more molecules of our magnesium carbonate. So experiment 2 is the one that will take place at a higher rate. Now we are supposed to explain the answer by referring to the collision theory. By referring to the collision theory. Né? Okay. By increasing, guys, the surface area, because I believe that, guys, the mass of our magnesium carbonate is the same, unless they told us that the mass is different, you know. By increasing the surface area, guys, of our magnesium carbonate, we are allowing more molecules to be exposed, number one, and hence we'll have more effective collisions per second, or rather, let me say, we are allowing more molecules to be exposed, such that more molecules will have will collide in a correct orientation per second, number one, and then we will end up having more effective collisions that will lead up into a higher reaction rate. Are you together? Whenever we increase the state of division of our magnesium carbonate, more collisions will be exposed, and hence they will collide in a correctly orientated manner, and hence we will have more effective collisions per second, and that's why experiment 2 will have a higher reaction rate compared to experiment 1. Okay, and then now we are told that the learners measured the rate at which carbon dioxide was produced in experiment 2. Okay, and they found that the learners measured the rates at which carbon dioxide was produced in experiment 2 and found it to be 0.25 grams per minute. It took 10.44 minutes to measure the time taken for the reaction to reach completion. Okay. They want us to calculate the mass of magnesium carbonate that was used. Okay. We will use magnesium carbonate, guys, to form carbon dioxide, number one. Are you together? So if we can find the amount of carbon dioxide that was formed, we can therefore find the amount of magnesium carbonate that was used. Are you together? So the information we have, according to the information we have, we will be able to find the amount of carbon dioxide that was formed. You know? Okay, because we are told that the rate of reaction is equal to 0.25. But I know that rate of reaction is basically equal to the change in mass of carbon dioxide all over the unit time. Are you together? The change in mass is basically equal to the mass of carbon dioxide at completion minus the mass of carbon dioxide at the beginning of the reaction all over the change in time. Rate of reaction. We are told that our rate of reaction is basically equal to 0.25 grams per minute. I'm using mass, guys, because I was given the rate of reaction in grams per minute over there. Are you together? So that's 0.25 grams per minute. This is just the mass of carbon dioxide at completion minus the initial mass of carbon dioxide. At the beginning of the reaction, guys, we did not have carbon dioxide. Carbon dioxide was produced as a result of reacting magnesium carbonate with hydrochloric acid. Please keep that in mind. You know? So at the beginning, we had 0 grams of carbon dioxide. Are you together? The reaction reached completion after 10.44 minutes. So therefore, this can simply give me the mass of my carbon dioxide which was formed, you know. So 0.25 multiplied by 10.44, this will simply give me 2.61 grams. I now know that, okay, I formed 2.61 grams of carbon dioxide. Are you together? So for me to know how much of the magnesium carbonate did I use, I just need to change this mass into number of moles. Are you together? So therefore, the number of moles of carbon dioxide that were produced is just the mass of my carbon dioxide divided by the relative atomic mass number. That's 2.61 divided by the molar mass for carbon is 12, for oxygen is 16. But since carbon dioxide has 2 oxygens, I'm going to multiply the 16 by 2. I simply have 2.61 divided by 12 plus 16 times 2. Okay, please guys do round off your answer into 4 decimal places. 0.05931 moles. So the number of moles of carbon dioxide that were formed is basically 0.05593. It's 4 decimal, ne? It's 593. So therefore, for me to go and find the number of moles of carbon dioxide, or rather magnesium carbonate, I'll simply use my ratio and proportion. Remember that, guys, the ratio of magnesium carbonate and carbon dioxide is just 1:1. Ne? Since my coefficients are 1, the stoichiometric coefficient is 1 and 1, so the ratio is just 1:1. Ne? So this simply means that, guys, the number of moles of magnesium carbonate that were used to create carbon dioxide should be equal. The number of moles of magnesium carbonate that were used should be equal to the number of moles of carbon dioxide that were formed. The number of moles of carbon dioxide, we simply have 0.0593 moles. Are you together? So I now know the number of moles of my my magnesium carbonate rather. Therefore, I can simply calculate the mass. I know that number of moles is equal to mass all over the relative atomic mass number. Are you together? So this is just 0.0593 multiplied by the mass, and then over here I simply have my magnesium carbonate. Magnesium has a molar mass of 24, carbon has a molar mass of 12, oxygen has a molar mass of 16. Since I have 3 oxygens, I'll just multiply the 16 by 3, and hence the mass will simply be 0.0593 multiplied by the sum of 24 rather, 24 plus 12 plus 16 times 3. This will just give me an answer of 4.98 grams. So the mass that was used for magnesium carbonate is basically 4.98 grams. Are you together? That's the amount of magnesium carbonate that was used to form our carbon dioxide in 10.44 seconds. Okay, now we are supposed to calculate the molar volume of carbon dioxide if 1.47 cubic decimeters of carbon dioxide was released. So I know the number of moles of my carbon dioxide that were formed. This is equal to V all over Vm. Are you together? Whereby this V represents the volume of my gas, and then this is the molar volume of a gas. Are you together? Okay, I know the number of moles, guys. I calculated them to be 0.0593. Please remember that. And then I have 1.47 cubic decimeters all over the molar volume. I can simply cross multiply. I will end up having 1.47 all over 0.0593. And this will just give me 1.47 divided by 0.0593. This will simply give me an answer of 24.79 cubic decimeters. So the molar volume, guys, at that particular temperature, it was just 24.79 cubic decimeters. Vm molar volume is 24.79 cubic decimeters. Okay, and then now we are told that the graph below represents Maxwell-Boltzmann distribution curve for carbon dioxide produced in experiment 1. Redraw the graph in your answer book. Clearly label the curve as A on the same set of axes. Okay, so this will be A, and then we are told that on the same set of axes, we must sketch the curve that will be obtained for carbon dioxide if the mass of magnesium carbonate is used is increased. Okay, whenever guys whenever we increase the mass, that means we'll form more amount of carbon dioxide. Ne? Nothing changes over here. So the only difference is that the peak will be higher. Are you together? We'll just have a higher peak just to show that more particles will have an average kinetic energy to collide, and then obviously we'll end up having more collisions, more effective collisions as compared to the previous experiment. Yeah, so that's how guys we're supposed to tackle this question over there. So please do stay tuned and wait for more videos. Thank you.